equals D divided by T. S equals D divided by T. S equals D divided by T. S equals D divided by T. Go! Speed. I'm bleeding lyrics so dope. You said they're getting whiny and you start to mope. Thinking how will I ever this math now deliver on a test or I never pretty much all ever. Well, shush. I mean just say hush. I'm trying to explain about speed and such. Go!
Today, we're going to learn how to interpret graphs of objects in motion. And the first graph that we're going to look at is a position versus time graph. It is very often that we will see it labeled position versus time or just D versus T, which refers to displacement versus time. So sometimes when I draw them, you may see us label them DT or D versus T. That's displacement or position. You interpret the graphs the same way. A position is where you are at an instant, and then we could find the displacement between any two positions because the definition of displacement is a change in position. So sometimes we label those graphs in both ways. What we see here is some typical data that we could plot on our calculator. Time is our independent variable, which would go on the X, and position is our dependent variable that would go on the Y. So you see that the points are plotted on the position versus time graph. By the way, when we name a graph, it is always the Y variable versus the X variable. When you see it in a table, the X variable is going to be on your left, the Y variable is going to be on your right. So if you're not sure which is the independent and which is the dependent, you can use the idea of the table where the X is on the left, the Y is on the right, or if you look at the title of the graph, or if I ask you to plot a D versus T graph, that will always be Y versus X. So when we look at the position time graph, when we plot our points, we're going to draw the best fit line. In this case, it is linear, and if you plug that into your calculator, you could find the actual value of the slope and the y-intercept. Or we can pick any 2 points along the line, and we can calculate the slope. We should already know from last chapter that the equation for a straight line is y equals mx plus b. Okay. When we plug that in to our calculator, or we want to calculate the slope, we know that m is the rise over the run. In other words, the change in the y variable between 2 points over the change in the x variable over 2 points. So when we talk about that equation, that's going to give us some information about the object. All I know at this point is its position over a certain time interval. Looks like we have 6 seconds of time. But if I look at that graph and I look at the units for the slope, okay, we said that the slope is equal to the rise over the run, or the change in y over the change in x. If I look at those units, the y units on that axis, so the y units are meters. The x units are seconds. So if I plug those in, meters per second, that is telling me that the slope of that graph is in meters per second. And over the past week and a half, we have been looking at a value of meters per second. Okay. The meter per second is actually how fast the object is going. So the slope of a position time graph is actually the speed of the object.
This is the time to put it to rhyme. It's D over Q that gives you speed. This is the time to put it to rhyme. MC Buttermilk, you're doing things.
If I look at the equation y equals kx, okay, you see it y equals mx plus b, or y equals kx. This is when our y-intercept is 0 or very close to 0. If I substitute in d, because d is on the y-axis, and then t, because t is on the x-axis, I can generate my first physics equation. Okay? The change in d equals velocity times the change in t. And we're going to talk about the difference between speed and velocity in a moment. Okay. We usually shorten this equation to d equals vt only when the velocity is constant. Okay. If our velocity is not constant, then we're going to talk about how to use this equation with the delta d and the delta t, and that's for next chapter. So one of the first physics equations that we're going to use is displacement equals velocity times time, and that's only when our velocity is constant. There's also something else that we can tell from this graph. So we can tell position by reading the y-axis, we can tell time by reading the x-axis, we can get the speed of the object by simply finding the slope, either using rise over run, or plugging this graph into our calculator and letting the calculator do the work to find the slope under your stat calc function. We can also tell the direction that this object is moving. If you remember from our first video, we talked about how positive and negative in physics indicate direction. So if I have a line with a positive slope, that means the object is moving in the positive direction. For us, that may be north, that may be east, we may say that's forward. If the line were to be sloped in a negative, so sloped down somehow, it would have a negative velocity. That means it might be traveling to the west or south or backwards. So just by looking at a position time graph, we can tell many things about the motion of the object. We can tell its displacement or position. We can tell the time at which something happens. We can tell the velocity by finding the slope. And we can even tell the direction that the object is moving by looking at whether or not our curve is sloped up or sloped down. Because we just introduced the ideas of speed and velocity, let's look at the difference between the two. Speed is a scalar quantity. It's how fast an object is moving. Velocity is a vector quantity. It is also how fast an object is moving. The difference is that speed does not have a direction associated with it, and velocity does. If we look at velocity, it is really the speed of an object plus its direction. Very much like displacement and distance, a displacement is a distance plus a direction. It is the rate of change of position. And the equation, the average velocity equals the change in displacement over the change in time, is the same equation that we just generated by using the slope equation. So slope is a change in the y variable, delta d, over the change in the x variable, delta t. These slope equations for displacement and velocity are going to be the beginnings of the motion equations that we use in future chapters. So it's very important that you understand how we generate them. Another example of the difference between velocity and speed can be seen in this black graph at the bottom of the page. The velocity is -5 meters per second. How do I know it's -5 meters per second? Number one, it's sloping down, so I can just visually see that. Number two, if I were to take the numbers, which I know that you cannot see very well, and I were to find the slope, it would give me a negative answer. The speed, however, is just 5 meters per second. So speed is the absolute value of the velocity, or the absolute value of the slope of a displacement time graph.
Yo, Mrs. A, I just got one question. I'm not trying to mess with you, I'm just trying to keep it real. What would you gonna do about something like this one?
The answer, if we have something curved, is that we can no longer find the average. In the problems you've seen so far in the graphical examples, we've seen the average velocity. When we have a straight line, we're finding the average. If we don't have a straight line, if we have something that's more like a curve here along the bottom, we can find the average between any 2 points. But if we want to find the value of velocity from this displacement time graph, we would need to find what's called the instantaneous velocity. Average is over a time interval. Instantaneous is at a particular instant of time. Okay. So it's when time approaches 0. It's such a small amount of time you can't even call it a time interval. So if we did have a curve, and we'll see these again next chapter, you can't just find the slope of a curve. You find the slope of a line that is tangent to the curve. Okay. And we'll look at tangent lines a little bit more next chapter.
It's not hours per mile, it's miles per hour. Miles is the distance like a sweet to the sour. Miles per hour, an hour's time. See the vibe like seconds, minutes, hours, alright. Know the distance move when you find the speed. But you need to know that time it'll need, so go. This is for time, I put it to rhyme. It's D over Q that gives you speed. This is for time, I put it to rhyme. MC Buttermilk, you're doing physics crime. Distance for time, I put it to rhyme. It's D over T and that gives you speed. Distance for time, I put it to rhyme. Speed is the less, won't even cost you a dime. MC Buttermilk in the house.